So far in Chapter 8, we have been using explicit rules. If I ask you for the 20th term, you can plug in 20 and give me the 20th term of the sequence. A recursive rule is a little bit different. Recursive rules are actually easier to write, but if I ask you to find the 20th term, it's more difficult to get to the 20th term. A recursive rule gives the beginning term or terms of a sequence and then tells us how to get the next term. So in this example, they're saying the first term is 2. So you're going to start with the first term, and then you're going to use this rule to get the next term. And then from that term, you can get to the next term. So you have to have the previous term in order to get to the next term. There's a new symbol that we're going to be using. It's this symbol right here. A sub n minus 1. This symbol means the previous term. And I find that recursive rules are the easiest if you translate them into English. So this thing in English says first term is 2. The next term is going to be the previous term plus 5. So we're going to take 2, that's our first term. We're going to add 5, and that will give us 7. Then we're going to add 5, and that will give us 12. Then we're going to add 5, and it will give us 17. Add 5, it'll get you 22. So plus 5 is really what's happening in this sequence. We're taking each term and we're adding 5 to get the next term. So the nice thing about this is if you know the first term and you know how it's changing, you can write the recursive rule and you're done. The problem is if I ask you for the 50th term, you're going to have to sit there and add 5, add 5, add 5, and keep going until you get to the 50th term. Evaluating recursive rules. So in your assignment, it's going to ask you to use this recursive rule to write the first 6 terms of the sequence. And I believe there's like blanks, like first term, blank, second term, blank. So this is a lot of mathematical mumbo jumbo. If you can translate this into English, it goes a lot better. So this is saying our first term is 1. So a sub 1, our first term is 1. That part's done. I'm just going to write this out. All right. This says your next term, a sub n, is going to be your previous term plus 4. So I'm going to actually write previous term plus 4. That means take your first term 1, add 4. What do you get? 5. Add 4. What do you get? 9. Add 4. Add 4. Add 4. So what you're really doing here is you're adding 4. The common difference is 4. You're adding 4. Just based off of what we did, what type of sequence is example 1? It is arithmetic. In example 2, great news, the first part of this is already done for you. Our first term is 1. I don't know why we started with 1 on both of these. Your first term is not always 1. Sometimes they start with 10. Sometimes they start with negative 14. It doesn't really matter, but they will tell you what your first term is. Then we look through here. Our next term is 3 times our previous term. So I'm going to write out 3 times my previous term. This means our pattern is times 3. So what is 1 times 3? 3. What is 3 times 3? 9 times 3? 27 times 3 is 81 times 3 is 243. Can I show you a shortcut that I really love in this calculator? So I do 1 times 3, then I do times 3. See how my screen says answer times 3? There's 9. You can just keep hitting enter now. It'll do it again and again and again. Fun, yay. I did not just get carried away on camera. Yeah, I totally did. Anyway, so I honestly kind of love recursive rules because they don't require a whole lot of thought. You just have to look through here and figure out what's the pattern. Once you figure out the pattern is times 3, just times 3, times 3, times 3, times 3, done. What type of sequence is example 2? If we multiplied by 3, it is a geometric sequence. Now, while recursive rules can be fun, they often aren't very realistic because if I asked you for the 75th term, that would be a little bit more difficult to get than if you had the explicit rule. However, there are some interesting sequences that you can create using recursive rules that finding an explicit rule for that sequence is very, very difficult. But before we get to that, arithmetic sequence and geometric sequence, here's the rules. And I left blank because a sub 1, that could be any number, whatever number it is you start with. But you have to list what your first term is, and then you have to describe what's happening. And you need to get familiar with this symbol a sub n minus 1 because that means previous term. So previous term plus something or something times your previous term. So let's write a recursive rule for the sequence. First, we have to decide what's going on here. Are we adding or are we multiplying? So this is the first time that we're combining both arithmetic and geometric into the same section. So we're going to have to really think about what's going on here. In number 1, I see fractions eventually, which makes me think that there's some division or multiplication going on. So I'm going to assume in number 1 that it's multiplication of something. It doesn't seem very obvious to me right now, so I'm going to do 40 divided by 100 and simplify that fraction to see what we're actually dealing with here. Four over 10, which is 2 over 5, so 2/5. So we are multiplying by 2/5, and you can check that. In your calculator, you can do 100 times parentheses 2 divided by 5, and you get 40, times 2/5, 16, and again 6.4, which is 32/5, and so on. So our common ratio is 2/5. We are multiplying by 2/5. Here's how you write the recursive rule. Our first term is, what is our first term? 100. The nth term is, we multiplied, so 2/5 times the previous term. Now, honestly, for geometric sequences, it's probably easier just to write the explicit rule, but if they want a recursive rule, here's the recursive rule. You can write these on the same line with a comma in between the two pieces of the statement, but often it's written vertically like this. Sometimes they might put like this symbol to connect it to say this is all one thing. All right, let's try number 2. What's happening in number 2? Plus 20. All right, so our first term is 8. Our nth term is the previous term plus 20. Ta-da! For some sequences, it is very difficult to write an explicit rule, but very easy to write a recursive rule for that sequence. The first one that we're going to look at is my absolute favorite sequence in the whole wide world. Does anyone recognize the sequence 1, 1, 2, 3, 5, 8? No? Okay. Has anyone seen the movie The Da Vinci Code with Tom Hanks? No? Okay. This is a special sequence called the Fibonacci sequence. And it means a lot to me personally, and I'll explain why with a video for those of you who care. If you're online and you really want to know why this Fibonacci sequence is so important to me, let me know. I'll share the video with you. It's pretty amazing. It's kind of like mind-blowing. Here's how this sequence works. 1, 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. The next term would be 5 plus 8. What is 5 plus 8? 13. And then the next term would be 8 plus 13 to get the next term. So you take the two previous terms and add them together, and that creates the next term. Here's how this looks with recursive rules. Our first term is 1. Our second term is 1. You actually have to define both the first and second term because the nth term is the previous term plus, if n minus 1 is the previous term, a sub n minus 2 means the term that comes before the previous term. Yeah. Now, if I asked you to write me an explicit rule for the Fibonacci sequence, that would be really difficult because you need to know the two previous terms in order to add them together to get the next term. So this is where recursive rules really shine because it allows us to write a rule for this sequence without having to go into the crazy math of trying to find an explicit rule for that.